Hi everyone, welcome back to another probability and statistics video. We are going over lesson 1.04 today on graphs of categorical data. So remember that we talked during the previous lesson about the difference between categorical and quantitative data. Quantitative was the data that was numerical or numbers, and our categorical data is categories or not numbers. So we're looking at interpreting circle graphs and single and multiple bar graphs, determining whether a circle graph or a bar graph should be used to represent categorical data, and then also taking a look at creating circle graphs and bar graphs. So a circle graph is a data display in which each slice, as you can see here in our photos, is a sector of a circle. The size of a sector shows how the value of that category compares to all the others. Many times, circle graphs include the percentages for each category, as you can see here in our photos as well. Sometimes circle graphs include counts instead, and you can see that in the photo on the left, we have our counts, and on the right-hand side, you can see we have our percentages. There are also situations where neither will be given, and then you can estimate the percent by the size of the sector, like shown here. Could you estimate the percentage of students who are non-religious? Again, we need to look down at our key. We can see that blue is Christianity, orange is non-religious, and the gray is Islam. We look at the non-religious sector, and we can see that it's about half of the circle. So we would estimate that the percentage of students who are non-religious are about 50%. So when should we use a circle graph? Well, think about the whole percentage. The percentages all have to add up to 100%, which again represents the whole. So when the categories can form a whole, like a whole student body, or a whole amount of sales for a year, circle graphs are better than bar graphs. But when you're trying to just compare parts to other parts, then sometimes it's better to use bar graphs. Let's take a look at interpreting circle graphs. You can use what we've covered back in 1.02 with our prerequisite knowledge on percentages to interpret circle graphs. When interpreting a circle graph, it's important to note that the percentages shown have often been rounded to the nearest whole percent. So let's take a look at our example here. The survey results here show a survey taken by 482 visitors to a park system. In the survey, visitors were asked which amenity was their top choice. Our first question asks, how many visitors chose biking trails? So the first thing I want to do is look at which of these sectors represents biking trails. And I can see that that is our green sector, and it's telling me that that is 16%. So then I'm going to take my pen tool here, and I'm going to find what is 16% of the total, which we know is 482. Now, once again, we learned how to do this, or we reviewed how to do this back in 1.02. So if you need a review, please check that out. So we have to take 16% and rewrite it as a decimal, 0.16. Of tells us to multiply by 482, the whole. And if we do that, we are going to get, I'm going to pull out my calculator, 0.16 times 482, get 77, roughly. How many more visitors chose hiking trails than campgrounds? So now we're comparing hiking trails and campgrounds. There's two different methods to actually completing this problem. You can find 43% of 482, and you can find 12% of 482 and subtract, right, to find the difference. So 43% of 482 be 0.43 times 482, which would give us about 207. 0.12 times 482 gives us about 58. And 207 minus 58 gives us about 149. Now the other method to completing this is you could subtract the percentages right away. 43% minus 12% tells us that they differ by 31%. And then we would find 31% of 482. So we're going to take 0.31 times 482, and once again we get about 149. So you can see two different methods, same answer. Let's take a look at the steps to make a circle graph. If you know the counts for each category in a data set, you can use those steps to make a circle graph. So first we have to find the part to total ratios. And you do that by adding all the parts together to get the total, and then you divide each of the parts by the total. Then we're going to find the central angle measures for each sector. To do that, we multiply each of those percentages, those part to total ratios that we found, by the 360 degrees, which is the total degrees in a circle. And then lastly, we're going to use the central angle measures to draw the graph, and we're going to use a protractor to do that. Or you can obviously do this in some kind of program like Excel, which is already going to measure the angles for you. So I've included the steps here on the left-hand side so you can follow along. Whereas during a typical school day, a student sleeps for 6 hours, is in school for 8 hours, works a part-time job for 6 hours, and has 4 hours of leisure time. Create a circle graph that shows the student's typical school day. So I started setting up a chart here for us to keep track of the activity and the number of hours. Next, I need to find the percentage. We know that there's a total of 24 hours in a day. So from here, I have to take each of the parts, for example, 6 hours of sleep, and divide it by the total 24 hours in a day. You'll see that I have to do that with each of the parts. And if I do that, and then multiply by 100, I get my percentages, 25%, 33%, 25%, and 17%, respectively. And from there, remember, I have to multiply each of the percentages by the total degrees in a circle, which we know is 360 degrees. And if we do that, we'll get 90 degrees for sleep, 120 degrees for school, 90 degrees for a job, and 60 degrees for leisure. And then we can create our circle graph here. So here we have 60 degrees. Here we have 90 degrees, or a right angle, for those of you that remember your geometry. And then we have 120 degrees here. Now, most of the time when you're creating a circle graph, you're not putting the degrees. That's important for you to create it. Usually then you label using the percentages. You will be doing this for your homework assignment. You'll be creating your own list of daily activities and then creating a circle graph for them. Let's talk a little bit about bar graphs. I'm sure you've dealt with bar graphs in your previous math careers. These are really important when comparing categories. So while circle graphs are best suited for comparing a category to the whole, bar graphs are best suited for comparing one category to another category. For example, consider comparing the test performance of 4 students in a class of 25. We're not comparing all 25, just 4 of them. The scores are not parts that form that whole. Again, we're not looking at the whole 25. Each test score is independent and is measured against a total possible. Now take a look a little bit at this misleading information. We didn't look at it on the previous page, but you can see these two graphs actually show the same exact information. They show Natalie, John, Haley, and Isaac, and the scores that they got on the same test. But notice that the axis is different. The axis on this top left one is 0, or it starts at 0, whereas the axis on the bottom right one starts at 70, which creates a misleading graph. It makes you think that Haley did a lot worse than Isaac. But if you look here, you can see that they didn't do a whole lot worse. Isaac scored around an 84, maybe 85, whereas Haley scored maybe a 76, 78. Not a huge difference, right? High C, mid C to a low B. Not a significant difference. Once again, this is just to point out that all of your bar graphs should always start out with an axis of 0, no matter what. Let's look at an example of creating a bar graph. So step 1, we want to identify the greatest value. So in our data of favorite protein pizza toppings, we're looking at 18 students who favor pepperoni. So that's our maximum. We'll use that greatest value to create an appropriate scale for the vertical axis, basically to make sure we have enough room on our graph to fit everything. And then lastly, we'll draw each bar according to its height. We're going to use a grid to make sure that all the heights are correct and to make sure that each bar has the same width. So I created my axis. I labeled. Notice that these all go up in the same increments of 3s. And you can see I spaced out my categories at the bottom evenly. And then all I do is add in my bars. Ham, which is up to 1, pepperoni, which is up to 18, chicken, which is up to 10, bacon, which is up to 7, and sausage, which is up to 3. And here we can see that pepperoni is much more highly favored than most of the other toppings. Which moves us on to interpreting a bar graph. Now, since you've had a lot of experience with regular bar graphs, I wanted to jump into talking about a double bar graph. This is useful for showing two data sets that relate to the same variable. Each category has multiple bars associated with it, and the bars are coded using this key here. If you looked at just the goals scored as shown at the top, it looks like Lisa and Haley, which you can't see names, I guess, but it looks like we have very valuable players here, right? Lisa and Haley. But if you look at goals and assists, right, you can see a better picture of how each player contributes to the game. Let's take a look at an example. The graph shows enrollments for the 6 seasons a karate school was open. In which season or seasons did the number of girls exceed the number of boys? So we're looking for when the girls, right, are greater than boys. So when the pink bar is higher. So we can see that this happens in late summer. But that's the only season. What was the total enrollment in the late spring season? We'll look for late spring. Total enrollment, we can see that there were 15 boys and 12 girls. And if we add those up, we have 27 total students enrolled. What was the ratio of boys to girls in late spring, in early summer? All right, use this time to check your answer. Thank you all for watching, and please take a look at your exit ticket today. Have a great day.